This period we're going to work on permutations. It's a new way of calculating how many different ways you can do something. And the important thing to know about this lesson is that this is when order matters. So get your objective in, pause, get your objective down, and then we'll go through some examples here. The first question that I have here is we are going to find out how many different ways, or we're going to review how many different ways you can order these letters A, B, C. Remember, if I drag those out, I can order them with A in the first spot, flipping B and C. Then I can have B with C and A in the second spot, flipping those guys around. And then we can put C, and then we can flip around our A and B. And so when you calculate this out, it turns out that we have six different ways of arranging the letters A, B, and C. The second question that I have here for review is about the commissioner planning the NFL draft, and it says that he lost the order for the draft. If there are 32 teams in the draft, how many possible orders are there for the draft? And in this case, they ask us to make a tree diagram. And so when we first start this out, we would have 32 branches of the tree. And my question to you is, why doesn't this seem reasonable? There must be a better way of doing this. So that leads us right into this first section of permutations. A permutation is an arrangement when order matters. So this might be a place where you make a list of things, or you might have like running a race, first, second, and third would be an example. In this case, the draft, it's better to draft first rather than last. You have more choices. This would be all examples of an arrangement. The formula for arrangement, or for the permutation, starts out like this. So it says, we write NPR. In this formula, the N stands for the total number of items. And the R stands for how many you choose. The formula looks like this. N factorial divided by N minus R factorial. The parentheses are important. Make sure that you have those on there, right here. And then the exclamation point is called the factorial. So the first thing that I have here is, what is a factorial? A factorial is where you list all the numbers, lower, and multiply. An example would be like if I wrote 5 factorial. That equals 5 times 4 times 3 times 2 times 1. Another example could be like 2 factorial. That would equal 2 times 1. This is your starting number, and you do every number lower until you get to 1. We started at 5, we multiply until we get to 1. And then you just put it in your calculator and calculate. So, this first question that we have here it says there are 8 people running a race. They're running the 200-meter race today at the track meet. How many different ways can they finish first, second, and third? If we were doing this yesterday, we would do it like this: first, second, and third. How many people could finish first? 8 of them. Then once one person crosses the finish line, how many could be next? 7. And then the last one, there would be 6 people to cross for third. We would multiply those 3 things together, and we would get 336 ways of finishing. But we can also do this using permutations. For a permutation, in this case, we have 8 people running, and we are choosing the first 3 places. 1, 2, 3. So we fill in our formula. It's a fraction. On the top, we do the n number. So we do 8 factorial on top. And on the bottom, we subtract the n and the r. So we do 8 minus 3 factorial. What that means is 8 minus 3 is 5. So now we really have 8 factorial over 5 factorial. If we write that on our calculator, or on our paper, we have 8 times 7, times 6, times 5, times 4, times 3, times 2, times 1. And on the bottom, we have 5 factorial, 5 times 4, times 3, times 2, times 1. It's really not as bad as it looks, because it turns out 5 cancels 5, 4, 4, 3, 3, 2, 2, 1, 1. And we really have 8 times 7 times 6. The exact same thing that we had over here. Our final answer is 336 ways that these 8 runners can finish first, second, and third. Now for question B. Back to that football commissioner. It says that the commissioner is planning NFL playoffs, and there are 32 teams in the league. How many possible orders are there for the top 8 teams to finish? Because order matters, first is better than 8th, we are going to set up a permutation. So we're going to take 32 teams and choose 8 of them. On top again is our n number, 32 factorial. On the bottom, we subtract the n minus the r, 32 minus 8 factorial. On top, we have 32 factorial, and on the bottom, 32 take away 8 is 24 factorial. You might think that this is a lot of numbers to write out. You can also use your calculator. If you look on your calculator, somewhere on there, there is a PRB button. If you're using one from school, you hit that PRB button, and if you arrow over, you will notice an exclamation point. Somewhere on your calculator, you have an exclamation point. You're going to type in 32 exclamation point divided by 24 exclamation point. All right, pause your calculator, or pause the computer, type that into your calculator and see what you get. I think when you're done, it should look something like this. 4.24 and then times 10 to the 11th. You might have a little 11 somewhere on your calculator. It might also say EE. That's scientific notation. If you remember back from science class, that's where you can take this decimal and move it 11 places to the right. This is really 4, 2, 4, 1, 2, 3, 5, 6, 7, 8, 9, 10. Oops, I think one too many. Let me write it there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That many ways the commissioner can order those teams. That is hundreds, thousands, millions, billions, 424 billion different ways the first 8 teams in the NFL draft, or the NFL playoffs, can be ordered. All right, flip your page over. We will finish the last few questions on the back side. Pause until you get ready. All right, these last couple questions. We have Mr. Nagan, Coach Nagan from Armstrong here. He's burning a demo CD for his new band, Falcon Pride Boys. They sing oldies but goodies, or maybe not so baddies, it says. His band has 12 songs in their playlist. However, he can only put his 4 best on the demo CD. How many orders can he burn 4 of the 12 songs on the CD? Now, the order makes difference because track number 1 is different than track number 4. This is like a list. And whenever you have a list, you have to do a permutation. So in this case, we have 12 songs. We're choosing 4 of them. 12 factorial over 12 minus 4 factorial using our formula. 12 take away 4 is 8. So we have 12 factorial over 8 factorial. Again, writing it out on your paper, 12 times 11 times 10. All right, I worked ahead a little bit and I got them all on there. Remember, we can divide out 8765431 with 8765431, and our answer turns out to be 12 times 11 times 10 times 9, or you can use your calculator and type in 12 exclamation divide 8 exclamation. All right, if you pause your computer, you can calculate that out. And if you calculate that, you end up with 11,880 different ways that he can arrange his songs. What I want you to do is read through the next 3 questions, decide if order matters in them, set up your permutation, and then I will show you the setups. So take a second, pause your computer, work through the next 3, and I will get right back to you. All right, I worked through these next questions. This next one, Mr. Lloyd is taking Ms. Hartman out for dinner. They have 7 side dishes to choose from. In this case, Mr. Lloyd does not have a permutation because order doesn't matter. Ordering a side dish doesn't matter what they put on the plate first, second, or third. That counts simply as a counting principle. And so for that question, you're just going to use the regular blanks, 7 times 6 times 5. For the next question, NBC has 15 comedy shows. They're going to put on the fall lineup. They're going to choose 4 of them. In this case, order does matter because 7 o'clock is different than 8 o'clock. This is like making a list. In this case, we have a permutation of 15 things, choosing 4 of them. So we set up our formula. 15 take away 4, it gives you 9. We keep working the formula. I'm sorry, it gives you 11. And when we plug that into our calculator, we get 32,760. Skip F, I guess that's a repeat. And the last one, the math department is going to the Star Wars Solo, a Star Wars story movie. And it turns out that 13 teachers are going and 4 teachers had to cancel. When they are standing in a line, that's like making a list. So permutation matters. In this case, it's a permutation of 13 things, choose 9. So we set up our formula. 13 factorial over 13 minus 9 factorial. Subtract that, we get 4. I did write it all out here if you wanted to show all of the work. The 4, 3, 2, 1 cancels on the top and the bottom. You're left with 13, 12, 11, 10, 9, 8, 7, 6, 5. You can multiply that out on your calculator, or you can also use your factorial button, and it turns out you get 259,459,200 ways those teachers can stand in line. Good luck on your worksheet. Make sure your notes are filled out. I will be checking those tomorrow. Have a great night.